Today we're going to specifically be practicing how to rank different molecules for their A value or their B value when we're in reference to the van der Waals equation. So here we have the question, rank the following molecules from the largest A value to the smallest A value. Now we need to remember what A is, and A is going to be my correction for the intermolecular force, which means that I am going to be searching for polarity. So as I draw out my Lewis dot structures, since I was not given them to start, I am going to be looking for polarity. So here I'm going to have N with a triple bond, and each N will have one lone pair. Then for oxygen, I'm going to have a double bond, each oxygen having two lone pairs. And then for HCl, I will have a single bond, H having no lone pairs and chlorine having 3. And then I will search for the most polar to least polar. So I'm looking for symmetry here. They're all 2-atomed molecules, so that makes it easy to go ahead and just draw through my axis of symmetry. So I have nitrogen and oxygen. We both have the same thing on either side. Whereas with this, I have a very clear difference here. So my HCl is going to be my most polar and therefore my largest A value. And now I need to differentiate between nitrogen and oxygen to see which one is going to be more polar than the other. So I have two things on either side. They are both very symmetrical, and now specifically I'm going to see how many lone pairs of electrons I have, because we do have a little bit of a dipole moment there where my lone pairs of electrons can attract things differently than electrons that are locked into a bond. So oxygen, O2, that molecule for oxygen is going to be the second most polar, followed by my least polar, which would be nitrogen in spot 3. My next problem is going to state that I am going to be ranking the following molecules from the largest B value to the smallest B value. Now remember that B is going to be my size, and so my largest B will be my largest molecule. So I can go ahead and just kind of do an initial count first to see who is going to be my largest. And so carbon monoxide here only has 2 elements, where CH4 is going to have 5 and CCl4 is going to have 5. So in my ranking, I'm going to go ahead and I'm going to establish that carbon monoxide is going to have a smaller B value than either of these two. And now to break this tie where we have the same we have the same value for both here, I'm going to actually check the masses. So we have carbon, that's going to be the same, so I don't really need to check those masses. I do need to check who is going to be heavier between hydrogen and chlorine. So hydrogen's mass is going to be 1.008 and chlorine's mass is 35.453. So obviously if I have 4 chlorines versus 4 hydrogens, chlorine is going to win out, and that is definitely going to be the heavier of the two, making CH4 my second largest B value and CCl4 as my largest. Next, I'm going to compare A values for all of these. So I have carbon monoxide, methane, and then CCl4. So since I'm comparing A values, remember that that's the intermolecular force, so I need to go ahead and draw the Lewis dot structure for these so that I can compare. Carbon monoxide is going to function rather strangely. It is a unique compound. It's going to end up doing something strange. So carbon is going to have a lone pair, a triple bond, and oxygen is going to have a lone pair. What happens here is that the rule of the octet rule is going to win out over either individual person being particularly happy with the situation. So oxygen's not happy. It only ever wanted 2 bonds, and now it had to completely donate a lone pair set to function as a bond so that carbon could have access to 8. And carbon wanted 4 bonds. It did not want a lone pair, so this one is not happy either. But this is what that Lewis dot structure would look like, whereas CH4, lonely to lonely here. And then redraw. And then CCl4. Drew those a little close. Okay, lonely to lonely here. And then I'll redraw that nice and pretty. And I'll add back in those lone pairs there. Okay, now I'm going to look for symmetry here, and my symmetry is going to be a little bit strange here. I'm going to have carbon monoxide, I have methane, and then I have my Cl4. So I'm going to go ahead and establish the ranking. So first I have carbon monoxide. Obviously we have a very different set on either side, but we do have matching lone pairs and a triple bond. A triple bond is extraordinarily nonpolar. So this is going to look different, but it's going to function a little bit similarly. Then we have CH4. We have a perfect symmetry set with no lone pairs accessible from the outside. So that's going to be my least polar. So I'm going to go ahead and I'm going to attach CH4 here. And then I have CCl4. So CCl4, we have lots of lone pairs accessible from the outside. We are symmetrical from either side, but those lone pairs are going to interact with things much more readily than my limited lone pairs for carbon monoxide. So carbon monoxide is going to be my second place, and CCl4 is going to be my first place. Last one I'm going to deal with is that I'm going to rank the following molecules from the largest B value to the smallest. B, remember, is going to be size. And so we have N2O2 and HCl. So this, we all have 2 atoms here. So we're going to end up needing to check the masses. So N's mass is going to be 14.007. Oxygen is going to be 15.9994. Hydrogen is 1.008, and chlorine is 35.453. So the N is going to end up being multiplied twice, which will give me a total mass of 28.014. Oxygen is going to end up being multiplied twice, which will give me a mass of 31 point, I think it's, I used to have this memorized. We'll go ahead and we'll cheat there, 15.9994. Oh, forgot to multiply by 2. 31.9988. Shouldn't have doubted myself. That's what I thought it was. And then I will add those two together. And so 35.453 plus 1.008 gives me a mass of 36.461. So that will be my ranking there, with my largest B value being that of HCl. My second largest is going to be that of O2, and my third largest, or my smallest, I should say, is going to be my N2.